Hey guys, Mr. Bowman here. We're moved on to the 2019 exam and we're focusing on all the algebra excellence questions from that exam. We're going to jump straight into question number 23. If you watched the previous videos, you know these are my favorite types of questions. So let's jot down the equation. So 36 times 6 to the power of 2x plus 6. When is that equal to 6x squared? So before I get into it, I can see a lot of 6's everywhere. And I can see the x squared and the power. So I'm thinking this is going to be a case of simplifying the base numbers, cancelling them out. That gives me a quadratic. I can go ahead and factorize and solve that quadratic. So let's see if that's the case. So 36, I'm changing that to 6 squared. So 6 squared times 6 to the power of 2x plus 6 equals 6 to the power of x squared. We're going to add the powers on the left hand side. So 6 will be the base number. Adding the powers together will be 2x plus 8. So I've added 2 to 2x plus 6. That is equal to 6 to the power of x squared. The 6's or the base numbers can cancel, leaving me with 2x plus 8 equals x squared. I've now got my quadratic that I talked about earlier. So I'm going to move the 2x and the 8 to the other side, resulting in 0 equals something. So 0 will be equal to x squared minus 2x minus 8. I'm now going to factorize. So what adds to negative 2 multiplies to negative 8. Hopefully you're thinking negative 4 and positive 2. So we've got x minus 4, x plus 2. My two answers, x1 will be equal to 4 and x2 will be equal to negative 2. So fairly straightforward question. A nice one to start off with for this video. Question number 34. We've got the plan for a rectangular garden given to us. You can see the whole garden, the garage and flowers in there, the rest being the lawn. If L is equal to x squared plus x plus 1, find an expression for the lawn in terms of L. So this question, when I first looked at it, it's going to be a bit irritating. Don't worry about this L nonsense for now. What our first step needs to be is coming up with an algebraic expression for the lawn in terms of x. We'll get to the L later on. So let's think about that. The approach I'm taking is what I'm going to do is I'm going to find the area of the total section, and then I'm going to subtract the area of the garden, and I'm going to subtract the area of the flowers, leaving me with the expression. So let's get into that. So area of lawn, I'll just write area. That's going to be equal to the dimensions, which is 8x plus 3 times 6x plus 2. So 8x plus 3 times 6x plus 2. I'm now going to subtract the area of the garage, which is 3x minus 2, 2x plus 1. So minusing 3x minus 2, 2x plus 1, and then going to subtract the area of the flowers down here, which is going to be minus x and then 2x minus 5. So this is the beginnings of my expression in terms of x. As I said, don't worry about this L nonsense yet. We'll get to L in a little bit. So let's dive through this messy stuff, see what we end up with. So that times that is going to be 48x squared. We've then got plus 16x, and then we've got plus 18x, and then we've got plus 6. We're then going to move on to the next one. Remember, we are minusing whatever the expansion is, so we're going to put a bracket there. So we've got minus 6x squared plus 3x minus 4x minus 2. And then we're going to do the rest of that. So we're going to minus, this one's a bit easier to expand, 2x squared. And then we've got plus 5x. Oh no, sorry, we're minusing that 5x, I think. So we're going to ignore the minus sign there. 5x. Okay, pretty messy. Let's simplify these two expressions here, and then we can expand those negative signs as well. So we've got 48x squared plus 34x plus 6 minus bracket 6x squared minus x minus 2, and then we've got minus 2x squared minus 5x. To these minusing of the brackets, so we're basically just going to make everything in the bracket the opposite to get rid of those. So 48x squared plus 34x plus 6 minus 6x squared plus x plus 2 minus 2x squared plus 5x. We're now going to group together the x squared. So we've got 48 minus 6 is 42, minus another 2 is 40x squared. We're then going to deal with the x's. We've got plus 1 gets me to 35, plus another 5 gets me to 40, so plus 40x. Then looking at the numbers, we've got 6 plus that 2 gets me to 8. So this here is my simplified expression for the area of the lawn in terms of x. We now can start thinking about this L nonsense, and the L does make it a bit trickier. And what I suggest is, if we look at this, it's 1x squared, 1x, and then the number 1. If we look at this, we've got 40, 40, 8. So what I'm thinking of doing is I'm thinking of changing that 8 to a 40. I can do that by plussing 32. But the issue is if I plus 32, my equation's not balanced. So at the same time, I'm going to go minus 32. So you can see plus 32 minus 32, they cancel each other out, so I'm not actually changing it. My equation's still balanced. So that there, when I simplify, is 40x squared plus 40x plus 40 minus 32. And I like this because we got 40, 40, 40. That's in the same ratio as the 1, 1, 1 in terms of L. So if I factorize out that 40, I've got 40x squared plus x plus 1, and close bracket, minus 32. And this x squared plus x plus 1, that's what L is equal to. So what I'm going to do is I'm going to take out that, and I'm simply going to go 40L minus 32. And that there is my expression for the area of that lawn in terms of L. So a bit of a weird question, very messy, more than likely to do a math error on the way, but we got there in the end. To question number 35, down the bottom there, I've got a messy equation. I've been asked to give the equation in terms of K for C, D, E, and F. And basically what that means is I need it to be K equals to something, and that something has C, D, F, and G involved. Simplest way to do this is write down the equation and get into it. So we've got F times K squared minus 9C squared is equal to 4D squared plus 16GK squared. So the first strategy I'm thinking of is, because I want K by itself, I want everything with a K on the left-hand side and everything without a K on the right-hand side. So what I'm going to do is I'm going to move this, there's a K over here, so I'm going to move this 16GK squared over. So I'm going to go minus 16GK squared minus 16GK squared. So that's been moved over. And this negative 9C squared, no K there. So I'm going to get rid of it by doing plus 9C squared plus 9C squared. So these cancel, leaving me with K's on one side and the other stuff on the other side. So let's simplify all that for us. So we've got FK squared minus 16GK squared is equal to 4D squared plus 9C squared. So I've got my expression here. I'm now looking to simplify the K part of it. I need K, just one K by itself. So these here, they've got the K squared in common, so I'm going to take it out. So K squared, bracket, F minus 16G, and that is equal to 4D squared plus 9C squared. That's unchanged. I can't really do anything with that squared yet until I get rid of that bracket, but that bracket is just multiplication. I can remove that by doing division. So I'm just going to take that to the other side as division. So I'm going to go divide by F minus 16G, which means that and that cancel each other out, and divided by F minus 16G over here. And this will end up looking like a big messy fraction. So I've got K squared is equal to 4D squared plus 9C squared over F minus 16G. Nearly there. The only step I've got left is that 2. I can get rid of a square by simply square rooting both sides. So that means k will be equal to the square root of, and it's going to be messy, 4d squared plus 9c squared divided by f minus 16g. And there's my final answer. Remember, square rooting can be plus or minus. So you should, out of habit, look to get that plus or minus there, but I don't think it was required for excellence here. I normally take time to think about simplifying what's inside the square root, but I couldn't really think of a nice way to do it here, and that turned out to be the case when I looked at the final answer. Question number 36, and we've been asked to find the value of y so that the area of the right angle triangle is the same as the area of the rectangle shown below. So that word same, that's our equation, that's our equal sign. So we're trying to find out when is the area of the rectangle equal to the area of the square. So that's how I'm going to start this question. So when is the area of the rectangle, or I said square before, definitely not a square, it's a triangle. Area of rectangle is equal to the area of the triangle. So that's our first step. We now need to somehow form some expressions for this triangle and this rectangle. Rectangles are base times height, so that's going to be 2y times 3y minus 1. So we've got 2y, 3y minus 1. When is that equal to? 1/2 of, so 1/2 times 5y minus, or plus 9, and then we've got 2y minus 2. So it looks like it's going to be fairly messy, this question. But what I like is this 2y minus 2. If you factorize that, do it over the side here so it's not messy, that's going to be 2 times y minus 1. So that times 2 and 1/2 out front are actually going to cancel each other out. So that leaves us with 2y times 3y minus 1 will be equal to 5y plus 9 times y minus 1. So you can see the 2 from that part and the half both gone, leaving us with y minus 1. Now this looks a bit easier to deal with, so I'm going to go ahead and just expand the heck out of everything. So we've got that times that, that's going to be 6y squared, that times that, minus 2y, that there is equal to, we've got that times that, 5y squared minus 5y plus 9y minus 9. I can now simplify that stuff I've got on the right hand side, those y's. So that's going to be 6y squared minus 2y, that's equal to 5y squared plus 4y minus 9. I've got a quadratic equation, so I'm going to go ahead and simplify it. The bigger y squared is over here, so I'm going to look to move everything to the left hand side, make sure that right hand side is equal to 0. So if I go minus 5y squared, these cancel each other out, minus 4y, and then we've got plus 9, those and those also cancel. So we've got, thinking of the y squareds, 6y squared minus 5y, that's 1y squared, so y squared. We've got 2y minus 4y, so negative 2y minus 4y, so that's negative 6y, and then we've got plus 9. When is that equal to 0? I look to factorize this, that's going to be y minus 3 equal to 0. This is a perfect square, so I'll make it look like a single bracket. Y minus 3 squared is equal to 0. And when I solve this equation, y is equal to 3. So that means the area of the rectangle and the area of the triangle, they'll have the same area when y is equal to 3. Question number 37. We've got two graphs sketching each other. We've got a parabola and a straight line. We've been asked to find the values for x for the 2 points when the graphs intersect each other. And this is a really fancy way of saying if we do this and we do this there where the lines touch each other, what are the x values that relate to those points of intersection? So we don't need to find the coordinates because it's just told us about the x values. And the nice thing is at those 2 points, the two expressions we've been given here, they are equal to each other. So we've got 7 plus x minus 6y squared. That's the parabola. When is that equal to 8x plus 4? And that was the straight line. So this is a quadratic. I'm just going to go ahead and simplify it. Make sure x squared is on one side, 0 or nothing is on the other side. So this is a negative 6x squared. I'm going to move it to the other side just to make it positive. That makes it easier to factorize. So I'm going to go plus 6x squared. Those cancel each other out. Plus 6x squared. And then we've got minus x, cancel, minus x. And then we've got minus 7, cancel, minus 7. So 0 is equal to 6x squared plus 7x minus 3. So there's my quadratic. And it is equal to 0, so I can go ahead and factorize. The 6 here is particularly irritating. Got to use the grouping method now. So 6 times negative 3 is negative 18. So I've got to think what multiplies to negative 18 adds to positive 7. Hopefully you're thinking positive 9 and negative 2. So I'm going to split that 7x up into 9x and negative 2x. So 0 is equal to 6x squared plus 9x minus 2x minus 3. So you can see that 7x is now represented by the positive 9x and the negative 2x. I now factorize the groups, so group number 1 and group number 2. 0 is equal to 3x x plus 3. Just a reminder, I'm single bracket factorizing here. Oh, just realized, so that should be 2x plus 3, shouldn't it? 2x plus 3. These here, they've got a negative 1 in common. So negative 1 and then 2x plus 3. And I've got the same bracket coming up twice. So this method is nice. It's self-checking, which means I didn't do any silly math errors. So 0 is equal to 2x plus 3, close bracket. My leftovers, 3x and the minus 1, form the second bracket. So we've got 3x minus 1. I've got my two brackets. I'm going to solve them each separately. 2x plus 3, when is that equal to 0? And the same with 3x minus 1, when is that equal to 0? So we've got minus 3, so 2x equals negative 3. Divide both sides by 2, which means the first value, the second value for x is negative 3 over 2. We're now going to do here plus 1 plus 1, so 3x is equal to 1. So I mean the first answer for x, 1 over 3. So there are my two answers. And that makes sense because we've got 1 over 3 here, that's in the positive area. And we've got negative 2 over 3 here, that's in the negative area. So those answers make sense. So that wraps up question 27. Moving on to our last question, question number 38. Short question, but it is a bit complicated. The straight line passes through these 2 points, is given by qy equals px plus 5. We're trying to find the values of p and q. So my first step here is, because I've been given 2 points, straight away I wanted to find the equation using y equals mx plus c. Thinking about the information I've got 1 point down here, that's negative 5, negative 10. And I've got another point up here, which is 9, 11. Just using this information to find out the rise over run. So there's my rise, and there's my run. So it is going from negative 10 to 11, which means it rises 21. And it is going from negative 5 to 9, which means it runs 14. So my gradient, m, is equal to rise over run. So I got them the wrong way around, 21 over 14. And they both got a 7 in common, so that there is 3 over 2. So putting that into my equation, y equals mx plus c, or I've written plus 3, but plus c. Y is equal to 3 over 2x plus c. I'm now going to substitute in either of these points as x and y to find that c value. I'm going to use the positive values, 9 and 11. So x should be equal to 9, y equals to 11, just because I'm less likely to make mistakes using the positive numbers. So we've got 11 is equal to 3 over 2 times 9 plus c. 11 is equal to 27 over 2 plus c. Simplifying all this, I'm just going to times everything by 2 to make the fractions a bit easier to deal with. So 22 equals 27 plus 2c. So negative 5 is equal to 2c. C is equal to negative 5 over 2. So I've now got my equation, my y equals mx plus c. So y is equal to 3 over 2x minus 5 over 2. Now that's in a different form. See how it's got p and q? which means we're looking for whole numbers or integers. So this one's very easy to figure out how to do that. If I times everything by 2, I can turn these fractions into whole numbers, and hopefully it resembles a little bit like the qy and the px plus 5 we were given. So let's times everything by 2, times 2, times 2, times 2. 2y is equal to 3x minus 5. So it's looking a bit better, but the only issue is we had plus 5, but our algebra has left us with a minus 5. So let's change everything to the other side. So this here is going to be negative 3x plus 5 equals negative 2y, which means negative 2y will be equal to negative 3x plus 5. And that now resembles what we had before. So we had qy is equal to px plus 5. So hopefully you can see the resemblance. So that tells us that q, so moving on up over here, therefore q is equal to negative 2 and p is equal to negative 3. So that wraps up that question, wraps up the last excellence question from the 2019 exam. Hopefully you found it useful. Keep an eye on the 2020 one. That's going to be the last one out for this year. Maybe we'll add some more later on as well. Who knows?